Lesson 817, Are They the Same? This is the first lesson in another section of this unit about congruence. You can see at the top of the screen, we're now in section 2, defining congruence. So today we're going to determine whether two figures are congruent just by looking. Let's take a few notes about the lesson we talked about in class today. We're on page 27 in your workbook. And our goal was to just be able to decide whether two figures are congruent just by looking. Decide whether two figures are, our new word today is congruent. Decide whether two figures are congruent just by looking. All right. So since we're talking so much about congruent, we're going to spend a little time with that word. And there's a symbol for congruent in case you don't want to write the whole word out. And I'm going to be using that symbol as we take some notes about congruence. And it looks like an equal sign with a little squiggle over it. That's the symbol for congruent. So if I write that symbol, I mean this word. Let's start with a definition of what it means to be congruent. And we're talking about two figures. Two figures can be congruent. So if a figure can be moved with translations, rotations, and reflections, so those translations, rotations, and reflections are going to show up again. Translations, rotations, and reflections. If a figure can be moved with translations, rotations, and reflections to fit exactly over another figure, then they are congruent. And really, this is what we've been doing all along as we've been rotating and translating and whatnot. I'm going to take just a moment away from these notes and refer to the activity that we had in class today. You can just watch right now. So we just said, if I can take this figure and just rotate it or translate it or reflect it to set it on top of this one, then I can say that these two figures are congruent. So it's kind of a weird figure. So I traced it onto some patty paper earlier, and I'm just going to see if I can woozle this around a little bit and get that shape to fit on top of the other. Yep, I can. So these are the same size, the same shape. They're just oriented a little bit differently. I can say that these two are congruent. And I'm just going to contrast that with these two figures. Now you can probably just look and see that this one's a little squashed down compared to this one. But if you're not sure, you can trace it onto patty paper and see if there's any way to turn it or flip it or rotate it so that it'll fit onto the other one. And I can't with this one, even if I flip it over. I can't find any way to make those figures fit perfectly on top of each other. So sometimes you can just tell, but if the figure is a little weird, like with a puzzle piece, where you have to look at the innies and outies there, and you're not sure if it'll line up with this one, draw it on patty paper. See if you can move it so that it fits over the other one. Yep, I had to flip it over, but I could make it happen. So these are congruent. So if two figures are the same size and shape, by rotations, reflections, and translations, then we can say they're congruent. Let's go back to the guided notes. So we just looked at some examples, but I'm going to draw my best anyway. If I have this figure here, and we are just going to assume I drew that perfectly twice, if I can translate that blue figure to fit on top of the red figure, then the two figures are congruent. Or if I tilt it to its side, and again, let's please just assume that these are all exactly the same. If I rotated this and it could fit on top of the green one, then these would all be congruent. But if they're a different size or a different shape, they're not congruent. So if I start with this, and then I have a little mini me here, those are not congruent. Or if I have one that instead of a rectangle, I have a square, that's not the same shape. So these are all congruent. These are not congruent. They're not the same size and shape. One last little thing we're going to say about congruent figures. In congruent polygons, those are closed shapes. We can say that the corresponding sides are congruent. So the sides that match up are congruent. I'm going to use my little symbol for congruence here. Corresponding sides are congruent. Corresponding angles are congruent. My little symbol again. And if I know they're congruent, then I can say the areas are congruent and the perimeters of the two figures are congruent. I'm sorry, their measures are equal. There's just a slight difference between congruence and equality. One has to do with shapes, one has to do with numbers. All right, so these are little facts about congruence. I think we're better familiarized with that term now. Here are some facts about congruent figures. First of all, let's fill these things in. We do not need to check all the measurements to prove that two figures are congruent. We just have to find a sequence of rotations, translations, and reflections that fits one figure on top of another. And we're well practiced with that. Translations, rotations, and reflections. It's and. So if we can find a sequence of translations, rotations, and reflections that match up the figures, then we can say they're congruent, just like we did a moment ago with these figures. Secondly, two figures that look like mirror images of each other can be congruent, but there just must be some kind of reflection in the sequence of transformation that matches those figures up. And two polygons that have the same area and the same perimeter are not always congruent. Let me show you what I mean. So they can have the same area and the same perimeter, believe it or not, but not be congruent. So look with me at figures A and F. We looked at these in the in-class activity. If I wanted to find the area of figure A, I would just count up all these squares. 1, 2, 3, 4, 5, 6. So the area of this figure is 6 square units. And the area of this figure, 1, 2, 3, 4, 5, 6, is 6 square units. So they have the same area, but that doesn't necessarily mean that this figure will fit on top of this one. This figure is 5 units long with a bump kind of here off to one side. This is 5 units long with a bump coming out here in the middle. One of these will not fit on top of the other. I'll prove it here. So I traced that earlier, and if I try to fit it on top of the other figure, they're not congruent, even though they have the same area. In fact, they have the same perimeter as well. Let me look here. I'm going to start here and just count around this figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The perimeter is 14 units. And same with this one. Let me start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They have the same perimeter and they have the same area, but that doesn't necessarily mean that they're congruent figures, as you can see here. There has to be a sequence of translations, rotations, and reflections that'll fit one on top of the other. So let's finish up. Sorry if that was on off screen earlier, but they're not always congruent. Let's finish up with talking about some ways to determine if two figures are congruent. Well, the way that we're familiar with, use tracing paper to see if one figure fits on top of the other. If that's a G, tracing paper. To see if one figure fits on top of the other. And that's really the same as saying, find some sequence of translations, rotations, and reflections ONS that matches up the figures. So we're moving on to talking about congruent figures in these next few lessons, and we're going to build on what you've already learned about translations, rotations, and reflections. Good luck with the homework for lesson 7.